In section 2.6, we're going to be talking about families of functions. The goal of this video will be to notice patterns when you look at an equation to see how it might be transformed from its parent function. So, to recap, a parent function is the simplest form in a set of functions. So as you can see here, I have f of x equals x squared. This is our parent function for quadratics. This is the simplest quadratic equation that you could have. Vertex is at the origin, most basic function you could have. Each function in a family, so in this case, the family of quadratics, is a transformation of that parent function. So for example, the equation f of x equals x squared minus 4 is that parent function shifted down 4 units. So in this video, we're going to be looking at different ways that you could transform from your original or parent function. The first kind of transformation we're going to look at is translations. You could have horizontal translation or vertical. So you could shift left, right, and up and down. Another type of transformation you could have is vertical stretch and compression. So to have a stretch, that means that we multiply all of the y values of a function by a factor greater than 1. Compression would mean that I multiply all of those y values by a factor between 0 and 1, so some fraction or decimal between 0 and 1. So just to visualize this, in this graphic at the bottom, f of x, that blue function, is our parent function. Picture stretch if you put 2 hands on the top and bottom of that graph and you stretched out that blue function. If I did that, I would get something that looks like that red function. That represents vertical stretch. And on the other end, if I took that blue line and I pushed in on both directions, I would kind of flatten it a little bit or compress it, what we can see in that green function. Sometimes it's easier to just kind of summarize these things, so I would definitely write down this chart, highlight it. This is probably going to be one of the most important notes that you write, probably in this whole unit or quarter. Vertical translation would mean I take that whole function and I add k units to shift it up, or subtract k units to shift it down. Horizontal translation gets a little bit more tricky. So I could have y equals f of x minus h or y equals f of x plus h. So here I'm kind of doing the unit on the x value. That makes it a horizontal shift. If I have something like y equals f of x minus h, that actually is going to shift the function h units to the right. Oppositely, f of x plus h will shift to the left. Finally, for vertical stretch and compression, if I have that whole function times the value of a, or coefficient of a, if that a value is greater than 1, that means it's stretching, and if that a value is between 0 and 1, that means that it's compressing. So let's look at some example problems. How is f of x equals x, parent function for linear equations, and f of x equals x minus 2 related? So f of x equals x is our parent function, most basic linear equation you can have, goes through the origin, slope of 1. If I graph f of x minus 2, that means I'm in slope-intercept form. I start at negative 2, go up 1 over 1. Now let's compare from the parent to our new function. It looks like I just shifted 2 units down. So that would be the transformation there. I shifted 2 units down going from my parent function. Part B, let's look at a quadratic. How is f of x equals x squared and f of x equals x minus 3 squared related? As we talked about before, f of x equals x squared is our parent function. And now let's actually just graph out in our graphing calculators f of x equals x minus 3 squared. When I do, I'm going to get a picture that looks like this. And as I can see, from that parent function, I shifted 3 units to the right. The last thing that we're going to talk about here is a reflection. A reflection, as you might remember from geometry, is basically like flipping your shape or flipping your graph. Just some notes to write down. F of x equals, or going to f of negative x would result in a reflection over the y-axis. The most common one that you'll probably see is f of x and then having just a whole negative coefficient in front of it, that would be a reflection over the x-axis. So just to see as an example, if I started the equation f of x equals x plus 2 squared, and I want to see how it compares to f of x equals negative x plus 2 squared, I'm going to graph both of them and compare it. F of x equals x plus 2 squared is going to look like this. Now f of x is equals negative x plus 2 squared is the same equation basically, but I have a negative coefficient in front of it. So it's going to look like that. And as I can see, it's reflected over the x-axis. Your goal in this video shouldn't be to memorize these in the short term. I would say for this kind of stuff, especially on a test or quiz, if you're asked any questions dealing with transforming from a parent function, you definitely want to use your graphing calculator to help you out there. If you can just see a picture of it, it's pretty easy to see if you've shifted, reflected, or stretched, or anything like that. The whole goal of this section is just to kind of highlight the fact that there are patterns between different graphs and different families of functions. And as we get into more complicated graphs throughout the year, your goal should be for May to be able to look at any kind of linear, quadratic, or any kind of equation and be able to make a prediction or generalization on what that graph might look like before you draw a picture of it. So again, just keep in mind, while we're learning these rules, I don't want you to just think, I want to memorize these in my head. Use pictures, use your graph, just know in the back of your head that there are patterns and just to be aware of them.